Hi everyone, thank you for inviting me to talk today about my research project on consumer health question answering and also visual question answering. First, I have to mention that the views and opinions are not those of the US government. Before diving in, I will present quickly my background. So I have been working on question answering for more than 10 years, starting with my PhD thesis that I did at the BMC lab in France under the supervision of Pierre Zwegenboom. And I have also a software engineering degree from the National School of Computer Science in Tunisia, and I worked at the Luxembourg Institute of Science and Technology on different projects related to natural language processing and also medical informatics. I was attracted by the research conducted at the National Library of Medicine, NLM, which is an NIH institute producing some of the leading research in medical informatics and also developing and maintaining important services such as PubMed, OpenEye, clinicaltrials.gov. So I moved from Europe 4 years ago to join the NLM, and I'm currently a staff scientist at the NIH. Some of the exciting projects at the NLM is the Consumer Health Question Answering Project, and it was initiated by Dina Demir-Fushman in order to help consumers finding relevant health-related information and find answers to their questions. There are some specific challenges related to consumer health question answering, as it could be entailed from this picture. I took this picture a few weeks ago at the office of my kid's doctor. So I will present some of these challenges through an example. This is a typical example of a consumer health question. So the questions start with, obese daughter, I'm a mother of 5 children, my son has leukemia, who is the youngest, my daughter is 12 years old and is obese. And then the question ends with, she's already been suicidal and her grades are so bad, please, I need help. So the entities or medical terms highlighted in blue here are relevant to find good answers. However, some of the entities or terms are not relevant, such as leukemia, and can bring more noise in automatic search and also more false positive results. Another challenge or issue in consumer health questions is, as you can see, the length of the questions and also the high rate of misspellings and ungrammatical sentences, which increase the complexity of an automatic analysis. This is the first results of a Google search using the full question. The first results don't answer the question. There are also many ads related to leukemia, which is not the main topic of the question. I was curious to see the results using short questions, so I tried with how to treat obesity in children. And the same, many results are ads, and also other results are from public forums such as Quora. And the second challenge here related to consumer health question answering is providing reliable health information in order to protect the consumers from misleading or harmful information. A good answer from the American Academy of Child and Adolescent Psychiatry, and it's also written in a consumer-friendly language meant to help parents, but this is in the third page of the Google search and using the short question and not the full question. So to address these challenges and to deal with the complexity of consumer health questions, I propose 2 approaches. The first one is based on recognizing question entailment, and the second approach is based on question summarization. So we introduced the task of recognizing question entailment in order to match a new question with pre-existing answered question when they satisfy the entailment relation. And we define the entailment relation as question A entails a question B if every answer to B is also a correct answer to A. This task allows reaching and using pre-existing answered questions to answer the new questions if they satisfy the entailment relation. I built a question answering system based on the ARCHI based on an RQE classifier. So first I use two information retrieval models to retrieve similar questions from a collection of question and answer pairs. Then I use an RQE machine learning model to classify these relations between the new question and the existing and similar questions as entailed or not. For retrieving similar questions and question candidates, I use the MEDIQA dataset. So this is a dataset that we created from 12 NIH websites, and it includes 47,000 question and answer pairs, and it covers 16 question types about diseases such as treatment, susceptibility, and 20 question types about the drugs such as usage and interaction, and it's publicly available. Then I tried different machine learning models for the RQE task. In my early experiments in 2016, logistic regression outperformed deep learning models when using traditional word embeddings, such as GLOVE and Word2Vec. But using the recent language models, such as BERT, outperformed logistic regression, as shown in the MEDIQA 2019 shared task. MEDIQA is a shared task that I organized with Chaitanya Chivadi and Dina Demner-Fushman at the ACL-BioNLP 2019 workshop. And in order to offer a new gold standard dataset and also a common evaluation platform, the references highlighted here in yellow are the only references and works on entailment and inference in the medical domain. Compared to thousands of papers on entailment and inference in open domain. And these, of course, using the SNLI and RT datasets. At the same time, there are very few efforts that studied the use of entailment and inference to improve the results of question answering. To the best of our knowledge, there are only 3 papers before MEDIQA, and 2 of these papers are cited here. So 2006 paper on methods for using entailment in open domain question answering, and a second paper in 2016 where we introduced the task of recognizing question entailment. So MEDIQA included 3 tasks: a task on natural language inference, recognizing question entailment, and question answering, all of them in the medical domain. And we also encourage the use of the NLI and RQE systems to improve the question answering performance. The challenge attracted 72 teams from both the industry and academia, and they proposed really interesting approaches and achieved great results. So if you are interested, the overview paper and the 20 working note papers are published in the proceedings of ACL 2019. The RQE-based question answering system is used in the CHICA system. CHICA is the first consumer health question answering system available at chica.nlm.nih.gov. And in CHICA, we use only trusted answer sources to answer consumer health questions. In CHICA, we have 2 modules, the RQE-based system and also another module developed by Yassine Mrambet, solution architect at the NLM, and it uses a classical question answering system based on question analysis to extract the question focus and the question type and an information retrieval model. We did a blind evaluation, manual evaluation, to evaluate the performance of each of the modules and also the combination. Using the hybrid approach, we achieve 1.3 average score using the TREC LifeQA 2017 benchmark. And the best result in the challenge was 0.6 average score. What's important to mention here is we achieved this result using restricted collections of answer sources compared to very large data sets that have been used by the participants, which means that restricting the answer sources help to provide reliable answers, but also improve the performance of the question answering systems. So the second approach to tackle the complexity of consumer health questions is question summarization. So this study started with the the observation of frequent peripheral information in many consumer health questions. This information could be related to the patient history or family. And this task aims to reduce the noise on the questions by keeping only the minimum information required to find good answers. To study the performance or the relevance of question summarization and question answering, we did a first experiment where we evaluated the results of the RQE-based system using the original questions and also their summaries written manually. So we submit both forms to the system, and using the summaries gave an average score of 1.1 compared to 0.6 using the full questions. And then I studied different machine learning and deep learning models for question summarization. So in the recent years, sequence-to-sequence attentional model became state-of-the-art in text summarization. The pointer generator network extends the sequence-to-sequence attentional model with a pointer network, allowing either to generate a new word or point to a location in the text source and copy the text word, which is interesting here because we can have both the advantages of extractive and abstractive summarization. As most of the research efforts and data sets in questions and text summarization are on article summarization of news articles, we had to create a new data set. So we created manually a new data set of 1,000 consumer health questions and their summaries, following our definition of question summarization. And then I tried different data augmentation methods to generate more training data. In the second method, I added questions asked by doctors, so clinical questions. And in the third data set, I added questions semantically selected from the Cora data set, so medical questions that I selected using the MetaMapply tool. So using the pointer generator trained on the third data set, I gave a Rouge 1 score of 44%, which shows the relevance of data augmentation for question summarization. This is an example of consumer health question received by the NLM and the summary generated by the pointer generator trained on the third data set. The summary of this 7 lines question is, can oscilla cause DVT, which is a perfect summary. It's also interesting to mention here that we achieved this performance of 44% Rouge 1, which is similar to the state-of-the-art results in questions in text summarization, open domain text summarization, using 8,000 training pairs, which is 2% of the size of training data used in open domain text summarization. So to sum up, our experiment showed that recognizing question entailment is a viable strategy for question answering, and also limiting the number of answer sources and summarizing the question can improve the performance of the question answering system. Yes, please.
Could you also evaluate the factual correctness of your summaries?
Sorry?
The factual correctness of your summaries, because like
yes, yeah.
Pointer generator is known to generate great coordinated summaries, but not necessarily correct.
Yeah, I have another slide actually that I can show. So we did a manual evaluation of 10% of the results. What was interesting is that here Rouge 1 score showed that the best system is the third system trained on the third data set, but the manual evaluation showed that the best system is the second system trained on the second data set. And this is one of the things and research project that I personally want to work on in the future, because we really need good evaluation metrics in order to improve our research and our systems. And we can't do it without having the right evaluation metrics. The problem of repeating and generating so with the pointer generator, the problem was repeating the same words many times. This is, I think, what you mentioned. And this is a frequent problem with abstractive models. and this is why they introduced coverage and used it to improve the system. But in my case, adding more training data improved the problem of repetition. So I didn't, this is why also the coverage didn't improve the results, because with the first data set I had repetition, but adding more relevant training data solved the problem.
Okay, so I wasn't, I was mainly saying about like, for example, if your summary says that like the gold summary says does this thing cause cancer, and your genital summary says this negates that, you know. There's little more change, but the meaning changes a lot.
Of course.
So
yeah.
I was wondering if you've seen such.
Yeah, and I think I don't remember this type of examples, but I know that yeah, Rouge 1 probably is not the best metric to detect this this case, and this is why we did the evaluation, the manual evaluation, to see how the pointer generator is really doing for summarization. Yes.
So you mentioned that the second method did better than the third method. Can you explain, like, qualitatively what sort of phenomenon were you looking at? Was it just the lack of repetition?
No, it was for the task of question summarization. So we're really keeping the minimum information that we need to find correct answers for the original question.
So they were just like more compressed, or like kind of what was sort of a...
So we also did error analysis, and we had 3 types of errors. The first is for some question we don't have the main topic. So it could be like a question about obesity or leukemia, but the main topic, main focus, it's missing. So this is a false summary. The second error is related to the question type. So the question could be about asking about what's causing this problem, but it's the question type, or this trigger or keyword is missing from the question. And a third problem, and which I think, so we had maybe around like 8% of the errors, it's semantically inconsistent. So it could be asking about treatment, but for a medication. So, and this I think could be also easily solved with some semantic rules and systems. Yes?
Were the gold summaries written conditioned on the context? As in,
So, the context is needed for some questions, for some answers, but not for all of them. So, as our rule and definition is based on the answer retrieval and retrieving correct answers, so if the context is needed to find good answers, we keep it in the summary. If it's not, it could be the age, for example, for some questions. But if you are asking about such, let's say, diabetes or a disease that we don't really need the context, we need to remove it from the summary.
sorry, what I meant was were gold summaries written in such a way that they'll generate the same answer as the original?
Exactly.
Okay.
Yes. Yes. So we also studied the questions about medications in order to see and study the needs and challenges for these specific types of questions. So we used questions submit to Midline Plus, and we used MetaMapLite to do named entity recognition, and then we manually selected questions asking about medications. And then we annotated manually those questions with the question focus, which is the main topic of the question, and the question type. And we also searched for answers online manually. We used mainly DailyMed and Midline Plus, as these are the websites recommended by the FDA, the Food and Drug Administration, for as consumer-friendly resources. But if we don't find relevant answers in these 2 resources, we can use any website. We did deep learning experiments for focus recognition and question type identification, and also for question answering using Chica. So all the results and systems are described in our mid-info paper, but here I will focus more on some of the insights from the data creation process and experiments. So the gold standard, the final gold standards contain 674 consumer health questions from Midline Plus, and their annotations and answers. 43% of the answers are extracted from Daily Med, 19% from Midline Plus, and 38% from other websites. For example, eHealthMe, which is a private website, had answers for some of the questions about interactions because we couldn't find any information on Daily Med, Midline Plus, and our preferred websites. This dataset covers 25 questions about medication, such as information, dose, usage, side effect, indication, and interaction. So the first set of challenges is related to the questions. So for example, it's very frequent to use many words or general terms to describe a medical term. Another problem is requesting medical information that is not written. It could be question about the usage of a specific medication that we didn't find, and it's not written anywhere that we can take this medication with or without food, for example, or in the morning or in the evening. And the third problem is under-specified questions, and this is the case of asking, for example, about the right dose of a medication without giving information about the patient or the condition. A second set of challenges is related to answer retrieval and even manual answer retrieval. So this is the case of conditional answers. For example, question asking about the color of a medication or the ingredients. We can't answer them without knowing the manufacturer. Distributed answers, where we need to combine or use two answer sources to generate a correct answer. And also the case of needing expert inference in order to retrieve the answer. Some of the solutions that we need to work on to improve question answering about medication is medical translation, simplification, and inference in order to retrieve the answers, but also make them readable by consumers and non-expert users. The second solution is having more data and resources, especially for some types of questions, such as interactions between medication or usage. And the third solution is for conditional answers, and is either with using inference-based approaches or dialogue-based systems for conditional answers. Do you have any questions about this part? We can also keep the answers to the end as well. So the fourth and last exciting project that I'm going to talk about is visual question answering in the medical domain. So visual question answering aims to answer natural language questions based on the content and the visual content of an image. And this task became very popular since 2015 with the introduction of the VQA challenge and the data sets of thousands of images and related question and answer pairs. Another existing data set is the VisWis data set of general images and related question and answers designed for blind people. For the medical domain, VQA is also relevant for clinical education and also clinical decision support. So we organized the VQA-Med challenge at ImageCLEF. And in this second edition of the challenge, I targeted 4 categories of questions. These categories are modality, plane, abnormality, and organ system. And I designed the questions and also the answers following some specific rules. For example, the questions ask only about one element shown in the image. And the answers are different for the 4 categories. For 3 of the categories, the answer could be generated using text classification models. But for the 4th one, which was the most difficult, more text generation models are needed to find the answers. So I created training, validation, and test set for the VQA-Med challenge using radiology images from the MEDPICS project at the NLM. The training set, for example, contains 3,200 radiology images with 12,000 question and answer pairs. And we, two medical doctors validated manually the answers of the test set. So here are some examples from the test set. 17 teams participated in this challenge, and the average, so the best blue score was 0.6, which is much higher than the performance achieved last year, which was 0.16 blue score. And this high performance is partially related to the new data set, but also to the several approaches that have been used, such as transfer learning, multitask learning, and hybrid approaches combining both classification and also text generation. And the working notes papers are published in the proceedings of CLE 2019. So before we close and get to Q&A, I wanted to share with you that the VQA-Med experience will continue next year, and we will organize the third edition of VQA-Med at CLE 2020 that will be held in Greece. So if you are interested, you have both great venue and also an exciting project to work on. For next year, we will work more on questions about abnormality, and we will also introduce a new task. All the data sets that I mentioned are available on my GitHub, and I hope I give you a good overview of our research project and also some of the community efforts on medical question answering. Thank you. Yes.
So you mentioned that there are two medical doctors who verified the annotations
Yes.
For the CLEF data. How did you get the annotation in the first place?
You mean for creating the first pairs of the original pairs of question and answers, or annotations?
So the medical doctor didn't write the question.
Answers, no. So I generated the question and answer automatically. So in the MEDPICS project, we have many radiology images, we have annotations, and I created the question and answers based on these annotations. What I used and helped me was, so last year we created VQA-Rad dataset. It's a dataset created by medical students. We published that in Nature 2018. So, and I used patterns from those questions and the most frequent types of question to generate automatically, to create patterns and generate those pairs. And then the doctors validated the answers for the test set. They did that for 500 questions and answers, but it took like sometimes 1 hour to validate only one question. So they were, what we did also is that if there is an optional part in the question, so we annotated that separately so that we can evaluate the results correctly. If there are different possible answers, we added also that. So.
And the answers are in the form of like a bounding box in the image? Or?
No, so it's text-based, yeah. So the answer could be the plane or the modality, for example. But another difference with the open domain VQA dataset is that in open domain they have one-word answers. And it's very easy to compute the accuracy, for example, and evaluate the systems. It's not relevant for us to use one-word answers. It doesn't answer all questions. So sometimes you have really long, not really very long, but we have long answers. So especially for abnormality, and this is why also for the results of the 3 other categories were much better than abnormality. Mm-hmm.
I think I might have missed it, but where were the images sourced from?
So it's the MEDPICS project, and this is a collaboration between the NLM and a medical school. So these patients actually upload and add their images, and with a radiologist validates all the images, and this used mainly for clinical education, so for medical schools. Mm-hmm. Yes. Yeah, go ahead.
So some of the questions that you showed as examples for these Q&A systems were very long. I
Yes.
wasn't expecting to see some of these questions be like 3 or 4 sentences worth of context, and I guess.
And these are not too long. We have much longer questions. We have 1 page.
So
A story.
Question: how typical are those of the types of questions that people ask? How complex do people get when they ask these questions of the Q&A system?
So it's very frequent to have very long questions, because I think it's easier for people to write about their story, I guess, and then thinking that if they provide more information, it will be more helpful, but it's not always the case. So some questions are really long. So when I started, like 4 years ago, the first project that we did, we manually annotated thousands of consumer health questions, and some of them, like I still remember the question, because they are very long, very complex, and sometimes very sad. Like you don't expect such complexity at all levels of the questions. Yeah. So in the current system, we integrated the RQE-based approach, but we didn't integrate yet the question summarization. But it's really like we need to do it in order to reduce the length of the questions. Yeah.
So to follow up on this question, where do you feel these questions? Are they from the PubMed search or from Chica?
This question, so they are mainly for the for the NLM, for the National Library of Medicine. I think some of the questions we get them also from other NIH websites. And these are from patients, from doctors, and from all over the world, not only the US.
Yeah, I meant just like which platform or which website?
So it's the NLM website, but also I know that we get questions from clinicaltrials.gov and other websites. Yeah.
Also to follow up on this, so when reading some of the questions, they don't necessarily even feel like questions as much as like kind of a cry for help in a sense. So like when people submit these questions to these sites, is the intention to ask a question, or is it the intention to start a conversation?
No, this is question for them. Yeah,
Okay.
it's
All right.
it's like also using Google and writing a question, right? I mean, for us, we know that we need to put keywords, right? And what I say also, like to my kids, these 2 keywords are enough. You don't need to write a sentence or 2 sentences.
Right.
But yeah, these are questions. Yes.
Yeah, it's just sometimes it feels like the actual question needs to be inferred from the much more general question. Like in that passage you showed, maybe it was like, what do I do, or how do I help her? But really, the question is, you know, how do we treat
It's true.
teenager with?
And for example, in our automatic system, if we have the keyword help, we look for treatment. So, yeah.
I guess also some of the information that they do provide could be useful to selecting a response if there's the need to look at the conditional information, for example, losing weight if you're on leukemia treatment or something might be different than just losing weight in general.
That's true.
I was wondering how so you had 2 suggestions on contextual information, but have you looked into representing that when extracting from the source?
So you mean when we need to keep some context information and when we need to...
Right.
So this is, we want to do it through the question summarization, because...
the other way. So when you extract the FAQ database,
Okay.
Preserving the contextual information there.
So in the definition that so my definition for question entailment was a question A entails a question B if the answer of the question B is a partial or complete answer for the question A. And because if you say how to treat diabetes, but I have this and this and this, like other problems, for example, or I have other, I'm taking medications, or so for this we need specific answer, right? But also providing general information about how to treat diabetes can partially answer the question. So, but with entailment, it's true that we remove some of the context related to the question. Yes. Yeah. Yes, please.
Also, just building on what Lucy was saying, it also seems like an interesting spin or other direction would be to connect people, do the same techniques to simplify the question and connect them with forums or groups of other people in the same situation, right?
That's
Because
true.
it does seem like a lot of times there's something a lot deeper than like, what do I do about my daughter? It's kind of like this need for
And
support.
this is a type of question that we have,
Yeah.
asking for groups or organization for a specific disease. Yes, yes, it's very frequent actually to have this type of questions. Yes.
I was wondering if you think it would be possible or useful to, with these like really long questions that possibly have many sub-questions and
yeah.
some of the text serves as better as context, whereas some of the text is actually the main
Sure.
question, to actually just do like more explicit extraction of structure, or modeling
Yes,
the structure of
yes,
the question.
yes.
So if
We
that's
have,
possible, or
So the Chica, the architecture that I showed, we have two main modules for question answering, but we have also other machine learning models, and one of the models is extracting the sub-questions and the background information. So we do that also.
So I guess it's the intention that like once you sort of partition and organize the main large question, then you do like question summarization on each individual question that's found there, kind of keeping them.
Yeah, I didn't think about it, but it could be relevant because we have the module extracting the background and sub-questions that we use as input for the classical question answering system, but we don't use it for summarization. But it could be actually interesting to see if having, annotating the background and sub-question helps for the summarization. Yeah, it could be interesting to try. Yeah. Yes.
One more question. So you mentioned you only use restricted sources for
Yes.
to find the answers. Could you tell us more about these restricted sources? Like
So,
how large?
yeah, so for the entailment system, I used only the MEDQA dataset. So we have 12 NIH websites, cancer.gov, Medline Plus, health topics, Medline Plus, drugs information, 3 collections from Medline Plus, and then from other institutes of the NIH, so Institute for Diabetes, and we have different institutes. For the classical question answering system that Yasin Rabbit built, it uses 24 collections, mainly from NIH institutes, but also Mayo Clinic and cdc.com or .gov. I think cdc.gov, yeah. This is the main website. Mm-hmm. Yes.
I could potentially see one scenario where somebody might ask about healthy eating or what should I eat to prevent flu.
Yeah,
or,
lifestyle
yeah.
question. Yes.
And they might say something like, oh, you should drink more orange juice.
Yes,
And
yeah.
then that might be contraindicated for certain medications.
Sure.
Has there been like a discussion about like mitigating like concerns around like giving people these incorrect answers?
Yeah.
And what was like the resulting like,
So yeah, so this is main concern for us to provide correct information, but this is also part of the question types that we have. So we have question about interactions between medication, but also interaction between medication and food. So this is also another task, because as you said, some, let's say, orange juice or medication can interact. I'm not sure orange juice, but I know that some food can interact with, or even some treatments can interact, other than drugs, interact with medications. This is one question type that we have, and we rely on the resources that we have to provide such information. So we don't take the risk of using other resources, but
but that requires that the user be aware of the question that they need to ask, whereas they could be unaware. And then it seems like it would be on the system to be able to like hold some sort of like conditional information or something.
But the question is about medication in particular, and you are asking if we add like. So I know.
The question was about healthy eating.
Oh, I see.
Right.
Mm.
And then it gave a answer that would be contraindicated by medication.
Mm.
But you don't know that information.
But you don't.
Yes.
So it's contextual.
Yeah, sure. Mm.
But that main question is just like, was there a discussion about like liability when you tried to say that we were going to put this online and allow people to like have their questions answered?
So if I'm not sure that I understand the question right. So you mean, So if we don't have information about the medication, we can't provide the answers, right?
Well, there was a study on like conversational agents like Siri. or
Yes,
like
yes,
Google
so
Now, and
dialogue.
about whether or not
It's true.
if you ask a question, it gave potential information that could be harmful to the patient.
Yeah, so like
Yeah.
do a dialogue to be sure. So I think like at ACL 20 this year, most of the papers that and presentation that I saw on question answering are on dialogue systems. But from our perspective, like we wanna solve the problem of question answering before going to dialogue approach and systems. So, but it's true, it could be very helpful and you can be sure about answering the right question and giving the information that the patients and consumers need, right? So you wanna ask, yeah, it's a good approach and can help, but right now we are focusing more on question answering before going to dialogue-based systems. Yeah. Yes.
I guess. Sorry, this is still, I guess, kind of in line because I like that lineup. I'm wondering if, in the setting when you're working with the dialogue agent, you can always sort of constantly query the consumer for more information, so you can kind of drill down into an answer that you're more confident in. But of course, there's complexities working on dialogue agents. If you're just working on a single like QA interaction, I'm wondering if maybe the formulation should just be for an answer. Long form answers are sort of should be like the gold standard, and you want to give like a long answer with a lot of prerequisites. So it's like, I don't know this information about you. I'm deciding
But
not to work in
case.
a dialogue setting, so I'm just going to give you a bunch of answers with a bunch of prerequisites or preconditions for like, if you are taking this, then this is the answer. If you're not taking this, then this is the answer, etc. But that might make the task much harder.
But also maybe what I didn't mention for both questions is that, for example, in daily med, there are warnings before providing information about the treatment, for example, or before giving information about specific medication, there are specific warnings. It could be like pregnant women can take this medication, or you can take it with this medication or food. So we provide this as we have this type of information in the answers that we need. Yeah.
So the answers are long form.
They are long form, sometimes very long, because some of the answers from cancer.gov, for example, you can't answer question about the treatment for a specific type of cancer. There are more than 100 types. We have different answers and treatments. It depends on the stage and in different factors. So what we are also working on is summarizing the answers. So and providing first, short summary, and then if you want to read more, you can have. And also maybe in the short summary, it's important to put the warnings and important information. It's true. Mm-hmm.
So
Yes.
there's this trade-off between giving overly long answers and giving misleading answers. Right?
Mm-hmm.
So was it easy to get the initial answer span generated? Was it tricky, or how do you think?
To generate the summaries.
Yeah.
We are still working on this. So we know that it's at least it's doable. So we can always present usually the first 1 or 2 sentences in answers is important and useful. So presenting like a baseline could be presenting the first sentences and the last sentences, and you have a good summary already. But what we are trying to do is studying extractive and abstractive summarization. At the same time, see if we can simplify the answers and present them in make them readable and more consumer friendly than the original answers. We are studying also to see if we can combine different answers in the same summary and if there are any contradiction or different information. So we are trying different configurations, and this is why we are not done yet, but as a baseline it's doable, and it could be done easily. Yes.
Great. So one thing I noticed is you mentioned the questions are coming from both consumers and also doctors.
Yes, many questions.
Can you just give like a descriptive how those types of questions differ? What's sort of different about them?
I think there is Dina did a JAMIA paper about describing the differences between consumers and expert questions. But for me, I don't know if there is, I'm not sure that there is a big difference. So for example, a question from a doctor could be, I have this case, I have this unique case of a daughter or a girl or a boy having this case, this type of cancer, for example, and in my country there is no other cases, or I don't know how to treat this this case. So so maybe there are some of the specificities that we need that makes the expert questions easier, that we know the medical terms, we have them in the questions. We know that generally they are well written, so we don't have misspellings and grammatical questions. So they are shorter than questions asked by consumers. Yes, I think this is the main differences, but there are no like really big. Another thing that for many of the systems that I built, I use the collection. It's called NLM collection of I think 1,400 questions asked by family doctors, and I use them for training models for consumer health questions. So, and it helps. So it means there are no big difference between the questions.
Is it fair to say that the answers that you want to retrieve
Are
should be
different.
very different for those two groups?
The same. Sometimes, like you have some parents, and maybe they read about that type of disease or problem more than a doctor, or they know very much about that specific case. Or, but it's true that you can provide answers from scientific articles, from yeah,
as opposed to something that's in a consumer
like more
health
exactly. Yeah. Yes. Yes.
Do you think it's a useful step still to do question type classification of the questions, or whether or not it's end-to-end for some of these downstream like, is it still useful for retrieval to do it that way?
To do question type identification?
Right.
Yeah, yeah. Yes, so we do. We have the classical question answering system, so we do question focus, question type, and we tried with keywords. So in the first collection that we created, we annotated also keywords and triggers of the question type. So we annotate what word triggered and help, like help, for example, that treatment type. But for question answering, for answer retrieval, triggers and keywords don't help. We need, so using the focus question type, we can answer 50% of the questions. So this is also based on a journal paper that Dina published, and we know that we can answer between 60 and 70% of the question if we have the right focus and the right question type. Yeah.
I guess it helps conditionally on the focus. Like if you know it's like a prognosis question, it's more likely your focus is going to be one of the entities that's related to like a disease type.
Mm-hmm. Yes. Yes, like semantic rules.
Right.
It's true. Yeah, or inference.
Expected answer
It's
type,
true.
I think.
Yes,
That's
yes.
the
Yeah, yeah. Yes, it's true. Mm-hmm.
Any other questions? Let's thank Asma.
Thank you so much.